Hi guys. I have super struggled this week. We took like an impromptu trip this week because my husband had the week off, and trying to learn all of this while on the road has just been really difficult. So I have spent a lot of time studying and watching a lot of videos to kind of narrow this down. Also, I heard on a video it was the Michaelis-menten, and I've been calling it Michaelis, so not sure what's right. But here I am going to do my attempt. I have everything written down on my computer, and then I'll just write down the equation and show you. Okay, so first, we're going to assume a reaction equation in which the enzyme, which is going to be represented as E, and substrate, which is going to be S, bind reversibly, and then go to form a product. So we're going to assume an initial reaction. So there is very little product in this, which will make the second back reaction negligible. So to start, I've got my E plus S. I'm just going to write it down quick and then I'll show you. E plus S. And make our reaction. E, S. Okay, so if you can see that here. So we have our enzyme plus our substrate. So K1 is going to be the rate of constant of forward, which is the first step. K negative 1, which is down right here, is going to be the rate of the constant of backwards of the first step. So then E plus S is going to give us the ES, so enzyme substrate, and then K2 right here is the rate of constant for the second step, and that's going to give us the enzyme, and P is our product. Then we're going to move on to step 2. So the initial state, which we're going to call VO, of the reaction is VO equals K2 times ES. So VO equals K2, which is going to be the rate of the constant of the second step, times ES, which is our enzyme substrate. Okay, so with this, the problem is that we can't know what ES is, what the enzyme substrate is, because it forms during this reaction. But we can make the steady state assumption that it is a low concentration that doesn't change because the state of its formation is equal to the rate of its breakdown. So this is going to give us our step 3. And this will give us our K1 times E times S, so enzyme times substrate, which is going to equal K1, or K negative 1 times ES together, plus K2 ES. Okay, so we have our K1. Again, K1 is the rate of the constant going forward, times E times S, so enzyme substrate, is going to give us K negative 1, which is the rate of the constant of the backward first step, times ES, the enzyme substrate, plus K2, the rate of the constant of the second step, times ES. Okay. So the problem with this is we also don't know what the enzyme is, which is going to be the concentration of the free enzyme, because some of the enzyme is bound. So we know that the sum of the free and bound enzyme is equal to the total enzyme concentration. So to write that down, it's going to be ET. T is going to be for the total enzyme, is going to be equal to E, and I'm writing this really fast, so sorry if you cannot follow my handwriting. We have the enzyme total is equal to the enzyme plus the enzyme substrate. So we're going to substitute the total enzyme into the steady state equation, which is our second equation right here, which is going to be the VO equals K2 times ES, enzyme substrate, and rearrange to solve for the ES. So let me write this down, number 5. This is going to be our K-1 times the E total minus ES, enzyme substrate, times the substrate, equal K1, or K-1. I always do that. K-1 enzyme substrate plus K2 enzyme substrate. Okay. Here's my equation right here, so you can see it. So K-1 times the enzyme total minus the enzyme substrate times the substrate is going to equal K-1 enzyme substrate plus K2 of the enzyme substrate. Now to go from here, move down to the second part of this equation, it's going to give us K1 enzyme total times the enzyme substrate is going to equal K-1 K1 times the substrate plus K-1 plus K2 times the ES. Okay. So moving down, we have our second part of the equation. K1 times the enzyme total times the enzyme substrate is going to equal, in parentheses, we're going to do this step first, K1 times the substrate plus K-1 plus K-2, and then once we get this total, we're going to times it by the enzyme substrate. So to move on from here to our third step of this step, third part of this step, we're going to have our enzyme substrate, which is going to equal K1 enzyme total times the substrate. I pushed too hard on my pencil, so the lead goes back in. Which is going to be over K-1 plus K2 plus K1 times the substrate. Okay. So third part of this equation gives us the enzyme total our enzyme substrate is going to equal K1 times the enzyme total times substrate over K negative 1 plus K2 plus K1 times the substrate. So from here, we're going to rearrange the expression to isolate the rate constant and then replace these constants with a new constant, which is going to be the Michaelis constant, which we're going to name Km. So let me get number 6 ready. So this, we're going to have our enzyme substrate, which is going to equal enzyme total times the substrate. All of that will be divided by K negative 1 plus K2, which will also be divided by K1. And then we're going to add that to the substrate. So, number 6, we have the enzyme substrate equals enzyme total times substrate over K negative 1 plus K2 divided by K1. You're going to want to do that step first. That's just why I have it in parentheses. We're going to take this total right here and add it to the substrate. From here, let's go to our next step. We're going to have our enzyme substrate will equal the enzyme total times the substrate, which is going to be divided by Km, which is what we just learned is the new Michaelis-menten constant, plus our substrate. So right here, enzyme substrate is going to equal enzyme total times the substrate, which will be divided by the Km, which is the Michaelis constant, plus the substrate. So this equation right here, K negative 1 plus K2 over K1, this right here is going to equal the Km in any equation. Moving on. So we're going to substitute the value of ES into the rate equation given by our first equation right here, which, the E plus S. So substitute the ES into the rate equation given by equation 1. The K2 can also be called the catalytic constant, which is the Kcat, because it represents the rate constant of this reaction. So this would give us, let me label this one, 7, that'll be VO is going to equal K2 times the enzyme total times the substrate over Km, our new Michaelis constant, plus the substrate. So here's the first part of that right here. VO equals K2 times enzyme total times substrate over Km plus the substrate. And then this is going to equal Kcat plus the enzyme total times the substrate. All of that will be divided by Km plus the substrate, which can be shown as right here. Sorry if my handwriting is too terrible for you. And then moving on to our final part of this equation, the maximum velocity, which is the Vmax, is going to be equal to the total enzyme concentration, which is the times the catalytic constant. So we're going to substitute Vmax into the equation to get the final form of the Michaelis-menten equation. So let me add this to step 8. So we're substituting Vmax. Vmax is going to be the Kcat times the enzyme total. So replace that with Vmax. So it's going to be VO is going to equal Vmax times the substrate over Km plus the substrate. So here is our final form of the equation. VO equals Vmax times the substrate. Remember, the Vmax is replacing this first part right here, the Kcat plus the enzyme total. So Vmax times the substrate divided by the Km. Km is half of the Vmax plus the substrate. So hopefully you were able to follow along with that. Like I said, this has been a really hard week for me. This especially was very hard for me, and I still don't totally understand it. But I mean, making this video and preparing for it has kind of helped, but I will be doing some more studying on it. So good luck, everybody.